This video is going to show you how to solve quadratic equations using the quadratic formula. First of all, I'd like to show you where the quadratic formula comes from so it makes sense what you're actually doing when you're using it. So the first thing we're going to look at is a generic equation for a quadratic. Now, what the goal is when solving any equation is to figure out what x is, so we're solving for x. So I have to get x by itself in this equation. The only way we're going to be able to do that is by something called completing the square. The first thing to do before you start completing the square is the x squared has to have a coefficient of 1. So we have to divide everything by a in order for that to happen. And so what we're left with is x squared, 0 equals x squared plus b over a x plus c over a. Now to complete the square, we're going to have to get rid of this c over a. So we're going to move it over to the other side by subtracting it. And so we're left with a negative c over a equals x squared plus b over a x. And now I need to put in a third term that will make this a perfect square trinomial. And so what we're going to add in is going to be half of b over a, so that's b over 2a, and then squared. So we're going to do b over 2a squared. And if I add that to one side of the equation, I have to add it to the other side. Alright, so let's work on the left side of this equation first. I'm going to square this term here in red. We're going to get b squared over 4a squared minus c over a. And we still have this side over here to work with later. Now I have to get common denominators over here, so we're going to go back to the left side. Common denominators, I need to multiply this by a 4a over 4a. We're going to be left with b squared minus 4a times c. Both of them are now over 4a squared. And we still have this other side hanging out over here. Finishing up this left side, we're going to combine the numerators to make it b squared minus 4ac all over 4a squared. And now over here I'm going to factor the right side, and since I made a perfect square trinomial, I know it's going to be x plus b over 2a squared. Okay. Now, we have to get x by itself, so we're going to take the square root, plus or minus square root on the other side. And let's focus on what we get. We get x plus b over 2a. And then over here, we get plus or minus square root of b squared minus 4ac all over. And since the bottom is a perfect square, I can make that 2a. And we have one more step to get x by itself. That is to subtract the b over 2a from both sides. And what we're left with here is the opposite of b plus or minus the square root of b squared minus 4ac. And I can put the whole thing over 2a because of the common denominators we have here. And there we have the quadratic formula. So what that means is when you have any quadratic equation, you can plug in the a, b, and c into the formula, and it will tell you what x is. So let's practice one of these. Let's say I had the equation 0 equals 3x squared minus 2x minus 10. Well, first thing you have to do is identify the a. Here's my a. b is a negative 2, and c is a negative 10. So if I were to write those out, your a is 3, b is negative 2, and c is negative 10. So all I have to do is plug those numbers into the quadratic formula, and it will tell me what x equals. So our quadratic formula, remember, is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if you solve that, it will tell you what x is equal to. So let's plug in our numbers. So the opposite of b is going to be 2. So since b is a negative 2, the opposite of negative 2 is a positive 2. Plus or minus square root. Now b is negative 2, so negative 2 squared minus 4 times 3, since a is 3. And we're going to replace the c with a negative 10. And that is all over 2 times, and since a is 3, 2 times 3. Now let's work on the inside underneath the radical sign first. We have 2 plus or minus the square root of negative 2 squared is 4. Then we have a minus, and 4 times 3 is 12 times 10. Negative 10 is negative 120. And 2 times 3 is 6. So 4 minus negative 20 is going to be a 124. So I have 2 plus or minus the square root of 124 all over 6 equals x. Now technically that is our answer, but we can simplify the square root of 124. Since 124 is equivalent to 4 times 31, we could make that be 2 times the square root of 31. So let's simplify that. 2 plus or minus 2 square root 31 all over 6 equals x. And since 2, 2, and 6 all have a common factor of 2, we can reduce them all by dividing by 2, and we get 1 plus or minus square root of 31 all over 3. So what does that actually mean? Well, that's actually 2 solutions. It is 1 plus the square root of 31 over 3, and 1 minus the square root of 31 over 3. Quadratic equation could have 2 x-intercepts and therefore 2 solutions. It could only have 1 x-intercept, in other words, the vertex could be on the x-axis, which means it only has 1 solution. And we could also have the situation where the parabola does not cross the x-axis, in which case we have no real solutions. And so what would this look like in the quadratic formula? The 2 solutions, obviously, is the example that we got here. Okay, these are your 2 solutions. Those are irrational numbers. All that means is your graph crosses the x-axis, or irrational numbers. So if we had 1 solution, what would happen is inside the square root, you would get a 0. So you would have something like 3 plus or minus the square root of 0 all over 3, for example. And since that is gone, the square root of 0 is 0, you're just left with 1 number, which would be 1 in this case. So 1 solution is when you have the inside the square root equals 0. And no solution, no real solution, would mean that you had a negative number inside or underneath the radical sign, because what that means is you cannot take the square root of a negative number, and therefore there are no real solutions. So there you have it. You've seen where the quadratic formula comes from and how you can use it to solve any quadratic equation.